Okay, question number 21 in the row 3 homework on OIO. We're going to use our knowledge about degrees and arcs and central angles to consider the following questions. Really what we're going to do is we're going to be relating it back to area and circumference. The first question, A, says what is the area of the watered section of the field, which is a sector of the circle with radius 15. So our base knowledge is whenever we have an area of a circle, we should remember we have a formula that says the area of an entire circle is pi r squared. Now this is for an entire or a full circle. But as you can see, we really don't want the area of an entire circle. The entire circle would go from here, and if I extend it all the way around, maybe ugly, but hopefully you get the idea. That would be the full circle. We don't want the full circle, we only want a portion of the circle. So what we do is we alter this formula just a little bit. If we do a full circle, that's 360 degrees. And if I put 360 over 360, pi times radius squared, what we'll get is the area of an entire circle. But we don't want the area of the entire circle, we want an area of a partial part. So what I'm going to do is I'm going to change the 360 on top. So to find the area of the circle, of the 360 degrees of a circle, we only want to have 120 of them. So we put 120 degrees over 360 degrees times what the area of a full circle would be. So this part here, the 120 over 360, is going to tell us the fractional part of the circle that we're going to find the area of. And if we reduce that, since they're both divisible by 10 and they're both divisible by 12, it'll give us basically a third of the area of an entire circle. So we only want a third of it. The only other thing that we need to know about this is that its area is based on its radius. So its area has to equal 1/3 of pi times the length of the radius, which is 15 squared. So we're going to take our 15 squared, which is 1/3 times 225 times pi, and our exact answer will be taking 225 divided by 3. So 225 divided by 3, a third of 225 is 75 pi. So the exact area would be 75 times pi. If you want an approximate value, what you simply do is you take your 75, so 75, and you take it times second, use your pi symbol, and you can get your most accurate answer there would be 235.6 the nearest 10. I think I saw that right, so I'm going to double check 235.6. And since this is area, it is square meters. So that is part A. Part B comes back to a different concept, and this time he wants to put a fence around the section. Now, when he fences this, the farmer not only wants to put a fence around the curved portion of it, but he also wants to put a fence around the straight sections of it. So we got to consider both. So the straight sections are pretty easy. We need 15 and 15, so we need 30 meters of fencing for the straight sections. Now I want to figure out how much fence we need for the arc section. So in order to find the outside edge of a circle, that relates back to the concept of circumference. So circumference is 2 times pi times radius. This is a typical circumference formula that we use. On this problem, what we need to know is that this formula finds the area, or the circumference, of the entire or full circle. So just like we did with our other formula for area, we're going to modify our circumference formula to figure out of the 360. Well, we don't really want 360 out of 360 of the 2 times pi times radius of our circumference. We're again going to change our 360 into the portion that we want. We only want 120 degrees of our entire circumference, 2 pi r. And I'm going to do a couple simplifications here, and then we'll do our calculation. So again, this is nothing more than 1/3. We want 1/3 of the entire circumference of the circle, so 2 times pi, and our radius is 15, I believe. I got to go back up and double check. Yeah, our radius is 15. So we can take 1/3 of 2 times 15 is 30 pi. And if we take a third of 30, that is 10 pi to be exact, or that's approximately 31.4 meters. Now that's for the arc section, so we want this, plus we also wanted the straight section, which we already added up and we said that was 30 meters, so we take our 30 meters plus our 31.4 meters, and it requires 61.4 meters of fencing to fence in that area. Okay, so there's a strategy on how to solve number 21.